What makes energy flow diagrams challenging in thermodynamics? Imagine trying to draw a map of how energy moves inside a machine or a power plant. It sounds simple, but it gets tricky fast. Energy flow diagrams are meant to show how energy transfers and transforms, but they have many challenges. First, energy exists in many forms, like heat, motion, or chemical energy, and each can change into another. Showing all these forms clearly in one diagram takes careful planning so nothing gets mixed up. Next, the diagrams need to be accurate in how much energy is moving. People often use arrow widths or pipe sizes to show energy amounts, but getting these proportions right is hard. Small differences can make the diagram misleading. When energy is lost as waste heat or other less useful forms, it adds more complexity. The diagram must show these losses without becoming cluttered, which is a balancing act. Another challenge is keeping the diagram simple enough to understand. If you include every tiny energy flow, it becomes confusing. But if you leave out important details, the diagram might not tell the full story. Finding the right level of detail is key. Also, energy moves over time, so arrows need to show the direction and timing of these flows. Dynamic systems, like engines or power plants, make this even more complicated. Defining the system boundaries is also tricky. You need to decide what is inside the system and what is outside. If you get this wrong, the energy calculations won't add up. The diagram must follow thermodynamic rules, like the conservation of energy and the increase of entropy. For example, it should show how organized energy turns into thermal energy, which is less useful for work. In real-world applications, these diagrams help analyze how machines or power plants lose energy and how to make them more efficient. For instance, in a power plant, the diagram shows how fuel's chemical energy becomes heat, then mechanical energy, and finally electricity. It highlights where energy is wasted so engineers can improve the process. Overall, energy flow diagrams are challenging because they need to visually and quantitatively capture complex energy changes while staying clear and accurate. Simplifying without losing important details and respecting physical laws makes creating these diagrams a real puzzle. But when done right, they are powerful tools for understanding and improving energy use in many systems.